The last topic in this chapter is dimensional analysis, which is really just unit conversion, which we saw a little bit with our temperature conversions and calculations with density, but now we'll take a more thorough approach to all of this. So what we want to think about when we're looking at dimensional analysis is we want to collect the correct conversion factors in order to make our conversion, like 1 inch equals 2.54 centimeters. And just like with density, we can flip our conversion factor around depending on what we're trying to do. So we can write it as 1 inch per 2.54 centimeters or 2.54 centimeters per 1 inch. And remember, for the purpose of significant figures, these conversion factors, we're going to treat them as exact numbers, so infinite number of significant figures. So this flow chart on the left here is saying, imagine we start with meters and want to get into inches, and we achieve that by going through centimeters. There's other ways to do it, but let's say that's the approach. So then what you see here are our conversion factors: 1 centimeter per 10 to the minus 2 meters, 1 inch per 2.54 centimeters. So we're going to do these kind of conversions in a single line. So we'll be able to do a lot more than we would if we did it step by step. So that's going to be the unique approach with our dimensional analysis. So let's follow along with this example and then get a general idea of how this is all going to work. We're going to start with what I call one-story conversions, where I have an initial unit with a given unit and I want to get into a desired unit. So the setup is going to be that I'll bring in my conversion factor as desired unit in the numerator and given unit in the denominator. And then that'll get me into the desired unit. So that's where we'll start with a simple thing like meters to centimeters, centimeters to inches. And in each of those conversions, we'll say the unit that we want to get into will be in the numerator. The unit we want to get out of is in the denominator. That's true in this case, but as we get to more complicated cases, we just want to be able to say broadly that we want our units to be diagonally opposite, so they cross-cancel. So let's walk through this example of 8 meters getting converted into inches. So our conversion factors in this case, it's 1 meter equals 100 centimeters, and 1 inch equals 2.54 centimeters. And we're going to line those up so that they cancel out appropriately. So we start with our initial value of 8 meters, and then meters in the numerator of the initial value. You can just, put this over 1 so it's clearly in the numerator. Meters in the numerator here cancels out with meters in the denominator in our first conversion, 100 centimeters per 1 meter. So that would get me into centimeters. And then in our second conversion, centimeters here cancels with centimeters down here in the second conversion. So 8 meters times 100 centimeters per 1 meter, that gets me into centimeters, times 1 inch per 2.54 centimeters. So then that's what gets me into inches. And when we solve for this, we find that our answer is 315 inches. So our first step, like I said, is to collect the appropriate unit conversions, and then once we get the appropriate unit conversions, then we can get into the new unit, whatever it is, just kind of in this single line conversion like you see here. So to just kind of reinforce the approach here, we want to be clear that we're making sure that our units we're trying to cancel are diagonally opposite from each other. Otherwise, it's not going to work. So the example that's crossed out down below here is basically I'm saying if I had my conversion factor upside down, then I'd end up with some sort of nonsense units. So it's really important to follow the cross-canceling of my units as I go through, because that kind of guarantees that what I'm doing is making sense. Okay, so let's practice some more of these. On page 2 of problem set 1, I think I gave you all the conversion factors that you need in order to do these problems. So these are all kind of these one-story conversions where I have a single unit that I'm converting into another single unit. So same as usual, right? Pause it if you want and work these on your own, or just keep going as I solve them. Okay, 264 grams into pounds. So the conversion factor that I found on the sheet is 1 pound equals 453.6 grams. So I want to get out of grams and into pounds. So pounds in the numerator, 1 pound. Grams in the denominator, 453.6 grams. So we know we're doing this correctly because grams cancel grams, and the units that are left are pounds, so that makes sense. We're going to treat our conversion factor as an exact number. I don't know that this one truly is an exact number, but what that means is since there are 3 significant figures in 264, my answer I will also round to 3 significant figures. So in doing so, I get 0.582 pounds. Okay, next one I'm going from centimeters to inches. So we know this conversion already, right? 1 inch equals 2.54 centimeters. So I want to get out of centimeters and into inches. So 889 centimeters times 1 inch per 2.54 centimeters. So centimeters cancel centimeters. I'm left with inches. It's in the numerator. That makes sense. That's what we actually get when we do this. 350. Again, same thing with the significant figures, right? 889 has 3 significant figures. The conversion factor is infinitely significant. The value I got was 350 inches, but to report it as having 3 significant figures, I need to put a dot after the 0. Not a 0.0, just a dot. So then that would be 3 significant figures, the 3, the 5, and the 0. Okay, next 2 will actually take us 2 steps, so we'll need 2 conversion factors, or at least I'm going to do it that way. My plan for this one is to go from inches to centimeters to meters, just kind of the reverse of the example we saw. So we know 1 inch equals 2.54 centimeters, and 1 meter equals 100 centimeters. Okay, with that information there, I should be ready to make this one work. 3960 inches. So I'll go to centimeters, right? So 2.54 centimeters. Centimeters in the numerator, 1 inch in the denominator. We know that's right because inches cancel inches like that. That's our first step in the process. And now I want to go to meters, right? So now it's going to be times 1 meter divided by 100 centimeters. Same story here. I know this is right because centimeters cancel centimeters, and then that leaves me with meters, so that all looks good. 3960 has 3 significant figures, so I should report my answer to 3 significant figures. I think it'll fit here. Let's see what we get. Calculator says 100.584. So to 3 significant figures, this would be 101 meters. Okay, one more to go here, seconds into hours. So we know 1 minute equals 60 seconds. 1 hour equals 60 minutes. So I'm going to do it in 2 steps, from seconds to minutes to hours. You can do it directly if you want to, but I'm just going to do it in 2 steps. So what do we have? 4, 4, 6, 4, 8 seconds. So that's 5 significant figures times 1 minute over 60 seconds times 1 hour over 60 minutes. We can verify that our units are canceling correctly, right? Seconds with seconds, minutes with minutes, left with hours. Let's see what we get here. I might write it in the line below just because I got a little crowded. I got 12.40222222. So to get 5 significant figures, it would be 12.402 hours. Okay, so those are our kind of single level conversions. So make sure you feel comfortable with those before moving on to the more complicated ones, but that's where we want to start. All right, so now we're going to start with compound units, so meters per second. So we saw density as a compound unit. Another common compound unit would be a speed, like meters per second or feet per minute, whatever it may be. And here it's asking us to go from meters per second to miles per hour. I think this conversion here, 1 mile equals 1609 meters, that's a really convenient one. I don't think you have it on your problem set 1 set. I just gave you miles to feet and feet to meters, but if you combine them together, you would get this one directly from miles to meters, which is particularly helpful for a lot of these. So we want to independently change meters to miles and also change seconds to hours. So we have all the conversion factors we need, but now we've got a compound unit, right? So when I think about the initial value, it's 343 meters per 1 second. So for meter, I'm going to use M, and for miles, I'm going to use MI, just so we're clear with our distinction. So our plan is to go from meters to miles, and I know it's already crossed out on my PDF, but if you're following along in the PowerPoint, it'll walk you through this process. But our first conversion factor is 1 mile per 1609 meters, so that meters cancel with meters. So now I would have at that point miles per second. Then 60 seconds per 1 minute, so that seconds cancel out. And then the minute here will cancel with 60 minutes per 1 hour. So we can see what's left after all of this is miles per hour. So that means we did things correctly. That's the correct units. And if I multiply this all out, remember, order of operation multiplication isn't important, just don't forget about anyone. We get 767 miles per hour, reporting it to 3 significant figures since our original value has 3 significant figures, and we're treating all of our conversion factors as exact numbers. Okay, so I have 2 of these for you to do, one in reverse, miles per hour to meters per second, and then the same as before, meters per second into miles per hour. So same story, pause it and work on it on your own if you want, or just keep going. So conversion factors for the first one, right? 1 mile equals 1609 meters, and then 1 hour equals 60 minutes, 1 minute equals 60 seconds. And so our plan will be miles to meters, then seconds to minutes to hours. All right, so let's see how this works out. 485 miles per 1 hour times 1609 meters per 1 mile. That looks good because miles are going with miles, and now I'm in meters. That's what I want to keep. That's good. Then 1 hour equals 60 minutes. And I know to write it that way so that hours are diagonally opposite and they can cancel. Then I don't want minutes, I want seconds, right? So 1 minute over 60 seconds. Same story here. Minutes cancel minutes. And I'm left with seconds. So what I'm left with is meters per second. So that's good. Let's see what I actually get when I do this multiplication. 217 will be my answer to 3 significant figures. It's 216.7 something, but 217 should be my correct answer to match the original 3 significant figures of 485. Okay, the next one is basically the opposite order, duplicating what we did on the previous page. So same conversion factors, we're just going to use them differently. 1 hour equals 60 minutes, 1 minute equals 60 seconds. So we're going to go meters to miles, and then hours to minutes to seconds. I forgot to do it up there, but usually I use this flowchart so I can check things off as I'm going along. Okay, so what have we got to start with? 1940 meters per 1 second. So to go from meters to miles, we'll say 1 mile equals 1609 meters. We know that's right because meters cancel meters. We're in miles, which is our target unit. Oh, and then that's our first step, right? Then 60 seconds, 1 minute. Seconds cancel seconds, so we're in minutes. And then 60 minutes per 1 hour. That looks good because minutes cancel minutes and we're left with hours, so we're in miles per hour. Let's multiply that out. We're going to report our answer to 3 significant figures like 1940 had. 4340.5 something, so we'll call it 4340 miles per hour. Okay, so the next thing to talk about is how to deal with squared and cubed units. So we have a general strategy for doing this rather than learning more unit conversion factors. So that's what I'll show you here. So what I did in this slide is noting what our conversion factor is between inches and centimeters. I drew a 1 inch by 1 inch square. Imagining, I don't think that's 1 inch, a 1 inch by 1 inch square. Might be close to get there. And then we know if it's 1 by 1 inches, then it's 2.54 by 2.54 centimeters. So then the area in inches would be 1 inch squared, whereas the area in centimeters would be 2.54 times 2.54, so it'd be 6.45 centimeters squared. So in theory, we could say, okay, we now know that 1 inch squared is 6.45 centimeters squared, but really that factor is just 1 inch squared equals 2.54 squared centimeters squared. So all we really need to do when we're working with squared units is square the entire conversion factor, including the numerical values. And if it were cubed, we do the same thing. We would just cube the entire conversion factor. So rather than learning a new conversion factor of 6.45, we just know if we're dealing with a squared unit, we square the conversion factor for converting that squared unit. If we're using a cubed unit, then we cube the conversion factor for that unit. Okay, so the example I have here is to convert 1.53 meters squared into inches squared. So the plan is meters squared to centimeters squared to inches squared. So in both steps, we're converting from one squared unit to another, so we're going to square the conversion factor. So the first conversion factor, 100 centimeters per 1 meter, quantity squared. So really that's 100 squared centimeters squared divided by 1 squared meter squared. That's a more convenient way to write it. So that's appropriately dealing with the unit being squared. And then in the second factor, 1 inch per 2.54 centimeters, but then we square the whole thing to say 1 squared inch squared divided by 2.54 squared centimeters squared. So in that previous slide, I was trying to help you visualize why this is the correct approach, because we're really changing both dimensions, so we need to square it. So then when I do that, right, it's 1.53 times 100 squared divided by 2.54 squared. What I ended up with was 2,370, 3 significant figures like my original value, inches squared. So we don't want to say square inches, right? We want to say inches squared to help remind us to actually square the conversion factors. Okay, one more of these, then we'll combine together squared and cubed unit stuff with compound units. So then if I were doing this for a cubed value instead, not a whole lot would change, right? I would just cube the conversion factor instead of squaring it. So in this case, going from, again, meters cubed to centimeters cubed to inches cubed. So I have to cube the conversion factor in each case. So the first conversion factor, 100 centimeters per 1 meter, quantity cubed. Second conversion factor, 1 inch per 2.54 centimeters, quantity cubed. And then lastly, I get my answer in inches cubed. So I'm multiplying 100 cubed and dividing by 2.54 cubed to acknowledge the cubed units. So this approach will always work. Just make sure you're only doing this sort of thing when you're working with squared and cubed units, and only for a step involving squared or cubed units. Okay, so a couple examples of these to look at. So same story, pause it and work on them on your own if you like. Okay, so inches squared to centimeters squared. So all I need is 1 inch equals 2.54 centimeters. So to set this one up, 1864 inches, inches squared, it'll be times 2.54 centimeters per 1 inch. And then I square the whole quantity, right? The number and the units, so that inches squared will cancel with inches squared. And numerically, I'm multiplying by 2.54 squared. And I got 12025, let me write it down, 12025.7824. That means this 2 is the cutoff number, and it's followed by 5 plus other stuff. So it'll end up rounding to 12030, where these four are all significant figures, so 4 significant figures, just like in 1864. Okay, how about the next one? Centimeter cubed to feet cubed. So I'm going to go centimeters cubed to inches cubed to feet cubed. So 1 inch equals 2.54 centimeters, and 1 foot equals 12 inches. I just need to cube things as I'm using them as conversion factors. Okay, 2152 centimeters cubed times, I want to get out of centimeters and go into inches, so it'll be 1 inch in the numerator, 2.54 centimeters, oops, what happened there, centimeters in the denominator, and then the entire thing cubed so that the units will cancel out. Now I'm in inches cubed, and I want to go to feet cubed. So now it's going to be 1 foot divided by 12 inches, then parentheses cubed. So now these inches cubed will go with these inches cubed, and my answer will end up in feet cubed. So it's 2152 divided by 2.54 cubed divided by 12 cubed. In this case, my calculator gave me 0.0759971, etc. The cutoff number, since it's 4 significant figures in my value, should be the second 9, right? That would give me 7599 as significant figures. In this case, right, the second 9 is followed by a 7, so that's going to round up. So this will actually become 0.07600. So here are my 4 significant figures, right? The first 2 zeros are placeholders, but those ones all count as significant figures. Okay, I think one more slide here doing compound units. So I'll show you what happens with these. So now the first one has pressure units, pounds per square inch, grams per centimeter squared. The second one has density units, but these are both compound units in which one of the units is squared or cubed, and we're trying to do a conversion. So here's the important thing, right? In the steps where I'm just doing a first power unit conversion, I do everything like we had been doing before. But if the step involves a squared or cubed unit conversion, then I need to account for that. So for example, in the first one, going from pounds to grams, I'm going to do exactly like I've normally been doing for a first power unit. But in the part where I'm converting from inches squared to centimeters squared, I'm going to need to square the conversion factor there. So let's follow kind of the approach I've been following, gather my conversions. So 1 pound equals 453.6 grams. 1 inch equals 2.54 centimeters. And I'm just going to say I'm going to go from pounds to grams, and then from inches squared to centimeters squared. Okay, so what do we have? 16.3 pounds per 1 inch squared. So looking at my information on problem set 1, I got my conversion factor, so we'll do that first. So we want to get out of pound and into grams. So grams in the numerator, pounds in the denominator. So these cross cancel and I'm in grams. That's good. Now I want to get out of inches squared and into centimeters squared. So 1 inch, 2.54 centimeters. quantity squared. So now inches squared will go with inches squared, and I'm left with centimeters squared. That's the plan. Let's see what we get here. So notice I only squared the length unit, the inches squared in this case, not the pounds to grams, because that's a normal conversion. Calculator gave me 1146, so this is going to round off to 1150, and that's going to be in grams per centimeter squared. Okay, last one to wrap this up. I think 63 is just blank, yeah. Last one to wrap this up, 9.34 grams per centimeter cubed to pounds per foot cubed. So a little more involved here, but we know 1 pound equals 453.6 grams. And centimeters cubed are going to feet here, so we need 1 inch equals 2.54 centimeters, but also 1 foot equals 12 inches. So in terms of my plan, right, pounds to grams, oh, sorry, no, it's grams to pounds this time, right? Grams to pounds. And then we're going to go centimeters cubed to inches cubed to feet cubed. So both of these conversions, right, centimeters cubed to inches cubed and inches cubed to feet cubed, those are cubed units, so I'll cube the conversion factors for those. Okay, so let's see how this goes. 9.34 grams per 1 centimeter cubed. And we want to get out of grams and into pounds, so it'll be 1 pound over 453.6 grams. Grams cancel grams, so we're in pounds like we want to be. Then we want to get out of centimeters and go into inches, and it's 1 inch, 2.54 centimeters. But more specifically, we're going from centimeters cubed to inches cubed. So we cube the entire conversion factor. Now I'm in pounds per inch cubed, so not quite there, one more step. 12 inches per 1 foot, quantity cubed. So now inches cubed cancel with inches cubed. So now I'm left with feet cubed. That looks good. So now I just multiply my way across. So same thing, right? When I was dealing with the cubed units, I cubed the conversion factor. But when I wasn't dealing with the cubed units, it was like normal. Okay, 9.34 divided by 453.6 times 2.54 cubed times 12 cubed. This gives me 583.067, etc. So I can just report it with 3 significant figures to match the original value. It'll be 583 pounds per foot cubed, which is a density unit, but not one that we're typically going to use. Okay, so that was kind of all things unit conversion all in one shot there. So hopefully that's making okay sense. Between the problem set and the homework, you should get the hang of this after doing some practice. The electronic homework kind of tries to help you frame the problems in terms of these unit conversions. So sometimes the formatting that they ask for in those is a little finicky. So if you get stuck on any of those, definitely let me know. I think I said this in my introductory video as well, but just on those homework problems, you have 3 chances, so don't burn all 3 without talking to me. If you email me, I'll get back to you pretty quickly. So if you feel like you're doing things right and it's just a formatting issue or something, shouldn't happen that much. Most of them work pretty well, but if you feel like that's the case, talk to me before you use up your last chance, just so I can kind of help you walk through it. And of course, if it just ends up being a formatting error and you did everything right, I'll give you credit for it. But just in general, I say don't burn all your chances before getting help from me. Okay, so that's it. That's the end of chapter 1. So in the next video, we'll start with the chapter 2, part 1 slides.